All right, stream started. Good morning, afternoon, everybody. Is that a little bit off center? No. Meh, it'll be fine. Hello, and welcome to Live Coding. Hopefully the stream will catch up. Oh, I did look into reducing the latency to see if there was some way that I could make it so that there was less of a lag between you typing comments and me actually seeing the comments and then the video of me reacting to the comments going up. And if I do that, then the maximum quality is lower that the stream is broadcast in, and something else that seemed like it was bad, and I don't remember what it was. So I chose not to do that. If that continues to be a problem, we will. I'll look into alternatives. Also, I know I need to update Chrome. I will. I just didn't want to do it before I started streaming. All right. Today, I'm going to implement softmax from scratch. And I know that I have in the past suggested that perhaps it's not the best use of your time to write code for things that already exist from scratch. And in general, I don't recommend that you do that. But in the reading group, I think it's become increasingly clear to me that I sort of have a broad understanding of what softmax is and what it does and how it's used, but I don't have deep intuitions about it. And that seems like an area for personal growth. So that's what we're going to work on today. And I am going to work in R just because I am extremely jet lagged and very tired. The reason I'm doing this earlier today than I usually do it is A, because it's better for folks in India, and B, because I hear the siren call with my bed, and I know once I go down for the nap, I'm just saving it. Dickie said, are you going to do it for image classification? Honestly, I'm just going to write just the loss function is my goal today, and we'll see how far I get. But in theory, you could use this for, image classification or any multi-class problem. So I have here the Wikipedia article open because I thought that would be a good place to start. And I could look at somebody else's code for the same thing, but my thinking was that I could implement it and then import somebody else's library who actually has worked on it and done some tests and stuff and see if we get the same results out. Okay, so softmax, and I'm going to do some reading and then I'm going to do some typing. Okay, and it looks like softmax actually can be used to discuss multiple things, so that might be something we want to figure out which specific one we are implementing. All right, in mathematics, the softmax function, also known as softargmax or normalized exponential function, is a function that takes as input a vector of k real numbers and normalizes it to a probability distribution consisting of k probabilities. That is, prior to applying softmax, some vector components could be negative or greater than 1 and may not sum to 1. But after applying softmax, each component will be in the interval 0, 1, and the components will add up to 1, so they can be interpreted as probabilities. Okay, so if we have the output of the final layer of our neural network, we'll have, whatever the weights have given us for each of our possible classes is usually the way that that's set up. So for every class that you're interested in, you'll have, a node in the final layer of your network. And that gives us, the list of the final values of every term in that node given an input is a vector. And what we're going to do is we're going to take that vector, turn it into a probability distribution. So it's scaling, right? It's not, so we're taking this range of things and we're squishing it so it's between 0 and 1. And so that the components will add up to 1. So if the output of our neural network, we had 3 classes and the output was 10,000, 0, 0, the output of softmax would be 1, 0, 0. And if the output were 1, negative 1, 0, the output of softmax would be, so it's squishing it, so the components add up to 1. So for something that's negative, that becomes 0. So the 1 would be, sorry, I'm thinking this through. So this is the first time I've ever wished I had a whiteboard here. So my understanding so far is that the expected output of softmax for that would be something like 66, 33, 0, because we're assuming that higher weights are a higher probability and that lower weights are a lower probability, and the lowest probability is going to be 0? I don't think that's necessarily, not necessarily the case. So, okay, let's keep reading. I'm just trying to, like, build my intuitions here. Little sip of coffee. All right. Components can add up to 1. Further, the larger input components will correspond to larger probabilities. Okay. Softmax is often used in neural networks. We've talked about quite a few of those on the channel to map the non-normalized output of a network to a probability distribution over predicted output classes. Okay. And that's usually if you have more than 2 classes. If you only have 2 classes, people usually use like binomial log loss or something like that, which I think is much, not just log loss, you don't have to say it's binomial, which I think is much more familiar, especially if you've already worked with neural networks, because it's like the sigmoid activation function. You're squanching everything down to be between 0 and 1. Okay. Prajeet says hi. All right, so the formula for this is the standard unit of softmax function theta, sigma, I think that's a sigma, RK to RK, so it's a, okay, so you have in a vector of k real numbers, you get out a vector of k real numbers, so we're not going to get any imaginary numbers out. Hi, Vidyasagar. And Philippe says sigma. Sigma. Thank you. Ryan says it renormalizes so that it adds to 1, but also increases results from higher outputs. Exponential of 0.8 moves less than exponential of 0.2, for example. Oh, I see. So it's not a linear relationship. We're not just moving everything and then squishing it together while maintaining the intervals. Because we're using the exponential, we're also sort of like pulling things up. Okay, and this in the paper we were reading on Wednesday, they said exp here, and I wasn't entirely sure what that function was. So it looks like we're taking what's that? Euler's constant? Oh, the number that we get the natural log from, and then rising that to 1 element. Okay, I get what we hear. So basically it's like the average. We are summing over all of so we're taking the exponent of each term, we're summing those, and then for each, shouldn't this be through k? For I equals, okay, 1 through k. Okay, so for each item in our vector, we take that item, we take its exponent, we divide it by the sum of all the other exponents, and then we move on to the next item and the next item and the next item. So we get out a vector of the same length, which is what this is saying. It's saying we're not changing the length of the vector, and also that we are not making any of the numbers non-real. And z, okay, so z are just, okay, I get this. So z is the specific item in the vector, and then I is the index of that item, with k being the maximum index. Oh, and now they say it in words, and I didn't have to do that. Okay, in words, we apply the standard exponential function to each element z sub I of the input vector z. I don't actually think you say sub I think you just say zi. The ith element of input vector z, and normalize these values by dividing by the sum of all these exponentials. This normalization ensures the sum of the components of the output vector sigma z is 1. Oh, I see the difference. One of the z's is bigger than the other z's. So the fat z is for the whole vector, and the skinny z here is a specific item for a vector. And that feels like some sort of, well, it's not set. That feels like a sort of a linear algebra notation. And I don't know if I mentioned this, but most of my linear algebra knowledge comes from working solely with MATLAB for a summer, which is a language that's built on the premise that everything is a matrix, basically. So I tend to have better intuitions with linear algebra, but not super familiar with the notation. Also, I think my other dyslexic out there will agree that mathematical notation is awful. It's really horrible. Like, you used bolding as the difference between two items that are, like, semantically very distinct. Math, folks. Okay, and they're saying you don't have to use base E. I forget what this is called. I know it's the one that's the natural log. A different base can be used as long as it's greater than 0, because if it were 0, everything would just be 1, right? No, everything would be 0, because 0 to any power is 0. Choosing a larger value of b will create a probability distribution that is more concentrated along the positions of the largest input values. Oh, I see. So, if b is very small, you are saying that you think that that if a network gives a very extreme output, you want to sort of like dial that in a little bit. And if b is very big, you're saying that a very extreme output is actually super informative, and whatever that is, that's probably extremely likely or extremely unlikely, and you're willing to skew it. So that's helpful. Writing b equals e beta or b equals e negative beta for real beta yields the expressions. Why are we... Okay, so this is just a different base. And it's the exact same formula, but instead of using e, we use beta of our choice, which beta can be anything. In some fields, the base is fixed, corresponding to a fixed scale, while in others, the parameter beta is varied. Advit says, isn't e to the 0 be 1? Yeah, I think it is 1. So that must be why b has to be greater than 0, because otherwise it would always... Well, no, because it looks like you're multiplying b by z here. Yeah, so you'll just always get 1 if it is 0. Yeah, thank you, that's helpful. I'm just sort of like, I'm digging out some very rusty math. Okay, this is making sense to me so far. So let's spin up a kernel and then come back to this. Andy says, I think of taking an exponential as converting a proportional scale to a linear scale. I'm not entirely sure what you mean by that, but I'm not sure that's relevant. Okay, we might come back to that, but I do want to spend a little bit of time putting my very fragile hold on this math into code. And I'm going to start in a notebook, but then when we're done, I'm going to move it to a utility script, which is a new feature we just launched. What is this even called? Softmax from scratch. Where the scratch is me like scratching my head. That's not what it is. And I'm going to do this in base R, I think. She says, we're using a Python kernel this time. Nah, I'm going to do this in R. Just because I'm very tired and I'm more familiar with R, so I think I'm less likely to make dumb mistakes. But let's see how that plays out. Okay, so let's start with a vector. So I'm going to call this K, keeping with the notation that the Wikipedia article is using. And I'm going to make that guy go small. And I'm going to start by just creating a very, like a little sample vector, but then we'll be able to, Anka says, please do it in Python. No, I'm so tired. I leave that as an exercise to the reader in the best tradition of math textbooks. Maybe next week when I'm a little bit more pepped up. All right, so what we're doing is I'm gonna write some pseudocode. So we want to loop. I'm not gonna do this in a loop. I'm just saying loop here is like a placeholder for me and my brain. Loop through the vector. Take the exponent of, actually, let me really quickly check if something's rattling. I think somebody's like working in the building somewhere else. Eater says, Rachel, put floats in your vector. Oh, that's a good idea. Oh, also, so just like a thing about R is, I believe by default, most numeric values are not assumed to be integers. You can specify that things are integers, but because it was written by statisticians, like, of course you're going to have decimals. What are you talking about? What is this sound? Well, that's really unpleasant. I don't know if you guys can hear that. Maybe a sandwich out of, like, metal drums. What was I doing? Oh, yeah. I just want to see if this is... Yeah, okay, excellent. That is a function in R, and that is what I would expect given... Euler's constant? Is it Euler's constant? I forget. All right, take the exponents of the ith vector, divide by the sum of the exp of all items in of the ith item in the vector, divided by the sum of the exponent of all the items in the vector, return new vector with output matching indexes. Okay, and Med says, yes, it is. Thank you. Again, I'm dusting off some stuff I haven't used in a while. Let's think about efficiency. So first of all, you never want to use loops in R. They are uniquely bad in R. And also in general, you want to vectorize wherever you can. I think the thing that makes the most sense is to take the exponent of every item in the vector. So I don't know why I'm doing this not under my pseudocode. So if I take x of k, first things, let's actually, oh no, I deleted myself. That's okay. Oh my god, I am tired. I'm using the wrong Simon operator. There we go. So C1, 2, 3, 0, 0.1. And then just take the exponent of it. So that's a thing. Fantastic. And then we want to divide by the sum of the exponent of k, which I believe is, yeah, so that'll be vectorized for us in R. And that's it. We did it. That's the whole thing. Med says, do you apply in R? So you can absolutely use apply in R, but when you apply any mathematical function to a vector in R, it's automatically applied over the whole vector using the C backend. So it's very, very fast. And I think we just did. I think we did it. I think we're done. Kumar says, probably we want to give more weight to the higher Z, and exponent will do that in softmax, just thinking. Yeah, I think you're right. I think we could also specify if we wanted a different base. JR says, is there any significant difference between the arrow and the equal operator when assigning? No, I prefer the arrow in general because the equal operator is used inside functions for argument assignment, and the arrow operator is not, but that is my personal preference. That's also the Tidyverse style guide, which is my personal favorite R style guide. But as long as you're consistent and consistent with your organization and their style guide, make yourself happy. Okay. Ito says, do it with loops and compare how much slower it is. Yeah, all right. I think that's a good and interesting thing to look at. The other thing that might be useful would be to look at how changing the... I'm out of frame. There we go. Would be to look at how changing the base changes the output. And also put this in a function. So let me delete this pseudocode, which I don't actually need anymore because I figured it out. And let's actually call this, let's make this a function. Let's call this base, let's actually just call it softmax, and then we can call the other things different varieties of softmax. Softmax, it's a function. Boop. It's a function that takes k as an argument and returns this. And so I'm not asserting anything, so if k is anything other than a vector, it's gonna throw up on me, but that's okay. Jess says, am I crazy or using Python logotype earrings? You are not crazy. They are. I don't know how you can see. Yeah, they were made by Thea Flowers, who's a Google developer advocate. She lasers them. And I saw her at PyCon. So I was at PyCon, and then I went directly from Cleveland to a team event. I'm so tired, you guys. And I saw her at PyCon, so yeah, I've got little Python earrings. They're super cute. I do want an R pair. Also, I am shocked that we did this in 20 minutes. I genuinely thought it would take much, much longer. There we go. All right. So here's our base function. And I really like the idea of also doing it with loops just to look at efficiency. So softmax loops, which I think will also, if you're not super familiar with vectorization, will be a little bit clearer what's going on. All right. She says, where can I buy? I don't think Thea's selling them right now. She does have an Etsy store, but she just had surgery, and I don't think there's any available right now. But yeah, I'll tweet about them when she puts them back up in her store. Okay, so we want to, let's be a little bit efficient and give ourselves a little bit of a cheat and do let's call this sum exponents, and let's, instead of looping through, take the sum of the exponents of k, just because I don't think it would be realistic to calculate the same thing in every loop, every iteration of the loop. I mean, you could, and there is definitely a point in my R career, my programming career, when I would have, and I would have been very wrong to do that. No, not wrong, but it's inefficient. It's not like super time efficient. So it's a better idea to try to avoid that when you can. And if you're calculating something inside a loop and you're using it the same in every iteration of the loop, do it outside the loop, so then you only have to do it once. And also, depending on your language's memory management and garbage collection, that can also be a memory thing. So R will allocate new memory every time you make a new a new item. So if you're making, you know, a big data frame in every loop, you can run out of memory. Sorry, this is a super tangent. I warned you guys. I warned you I was a sleepy baby. All right, and then we got to for I in. That's Python loop syntax. What's our loop syntax? It's been so long since I've written. Nope, that's not what I'm looking for. Don't want data camp. There we go. Software carpentry. It's been so long since I've written a loop in R that I straight up have forgotten the syntax. Okay, so the thing you're analyzing is for I in 1 through the L-E-N-G. Is it just len? Maybe it's length in Python. Okay. We want to, oh, and let's also allocate an empty vector, which I have also forgotten the syntax for. JR says it is length. Thank you. No, it's big. Sorry. L-E-N-G-T-H. There we go. What was I looking up? Empty vector in R. So that's another thing that's super bad about loops in R is every time you go through a loop, if you're adding on to the end of a vector, it will create a new version of that vector and again take up more memory and it takes more time. So you never want to use that could work. Okay, so you never want to add recursively to an object in R in a loop. So you don't want to use like rbind or cbind or C to put something on the end. And Med said it is R in Python. Adair says it's actually good that you don't remember the syntax for loops in R. It means you vectorize. I try. Oh, and Vladimir says you can write the test to assert softmax property sigma k plus c equals sigma k. What was c? I don't remember where we got I'm not entirely sure where you've gotten c from, Vladimir. What was I doing? Oh, also it's not that, it's those. It's a curly brace. We were allocating an empty vector, so let's do rep for that. So output is rep. Let's just say 0, and then we want to repeat that. Also, it's not how you spell output. Length of k times. Still not how you spell length. And then for each item in length of k, we are going to say that output at the ith index is going to be the exponent of the object of the item in your vector at the ith index. So k I, nope, that's not I. That's I. There we go. Divided by some exp, which we've calculated up here, and then we want to return output. Okay. I think that will work. Let's try this really quick because I think that. All right, no errors, no errors. It's a good first step. So let's do softmax k. Nope. All right, and then let's do softmax, what I call it, softmax loops. Softmax loops of k, and we should get the same thing out. We did, excellent. No errors in my loop code, which is nice. And Vladimir says c is a constant added to every vector item, and Ryan says I think c would be some small constant. That makes complete sense, right? Because it's a normalization function, so if you shift everything, you would expect the normalization process to shift it all back. That's a very clever test. Thank you. Okay. I'm trying to remember what the name of the benchmarking in R function is. There we go. Hadley will help me out. Advanced R, I don't know if I've shown you guys this. I have a physical copy, and if you're interested in working in R and doing so efficiently, it's a really good book. And if you're doing a lot of statistics in your day-to-day, I would recommend I'd recommend just investing time in learning R, because you'll save yourself time in having to implement statistical methods. Profile. All right. Source profiling example. That's more than I want to do, I think. Micro benchmark. Yeah, that's the one that I know. I'm not entirely sure. Okay, it looks like it's not already installed. Our micro benchmark. Hitting up the docs. Micro benchmark, blah, blah, blah. Accurate replacement of system.time to replicate 1000 EXPR. Do function f times. Okay, so we'll run copy. I'm just going to copy and paste this code, and then and micro benchmark is in what package? It's in the micro benchmark package, so I can do. I don't want to load in the whole package, so I'm going to just say, well, check it out. I'm going to look for it. And instead of f, which is the function that they defined, I'm going to use my function, softmaxk. And then I'm going to print my results. And blah, 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 blah. All right. That is the package name. Have I misspelled it? That's extremely possible. The other option is it's not micro bench park. It's not a park bench. Yeah, I misspelled it. All right. And this is going to take a bit. Oh, right. And then let's give it. Actually, let's create a longer vector for us. So let's just generate something with let's say 1,000 normal values. Sample 1,000 values from the normal distribution. And then I'm going to take that normal distribution, and let's add it to another sample of 1,000 values from the normal distribution, but these ones we're going to multiply by 100. Let's multiply them by 2. So I'm making one sample of the values from the normal distribution. I'm multiplying them by 2, so they're going to be, they're not going to be from a normal distribution centered around 0 anymore. That's going to make the differences bigger. And then I'm adding another 1,000 different samples from the same normal distribution. So I'm going to have 1,000 vector. A must be a numeric vector in norm. I thought that the name of the function was norm. R sample from normal distribution. This is definitely a built-in R function. R norm, excuse me. I did not say the name good. Blah, 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 unused argument. And I think it's not actually called X, it's called N. And I don't think we actually need to mess with it. But leave the default is softmax test. I believe the default is a mean of 0 and a standard deviation of 1. Test values, call this test values, which I think is just like a little bit more informative than test. And let's just only do 100 in case it ends up taking a while. All right. Object test values not found. Yeah, because I didn't run this again. Good job, Rachel. All right, so now it's going to run it a couple times. Okay, so zoom out a little bit so that it's sampled a little bit better. So we've got a mean, and this is in milliseconds, I believe, so a mean of 453 milliseconds, and, sorry, 47,172 milliseconds, and then a median of 45. Wait, can I directly compare two things? Okay, I think I should actually have been doing softmax loops test values. Because null just creates a null value, so we wouldn't expect that to take much time at all. There we go. So you can see that, so here is softmax without looping, and that takes about, 50 milliseconds. And then softmax with looping takes about, 150, 175 milliseconds. So not using looping and instead using vectorization, in addition to being like so much less code, is much, much, much faster. A little more coffee. Oh, and he's on a timer, says, I think it's our norm. It was our norm. Thank you. It's just like a little bit of a delay. So let's tidy this up a bit, and let's put this in a utility function. So there's specific our comments on function. There's specific syntax for writing comments on a function. Oh no, I don't like the Google R style guide. They have you put like dots in variable names, which, because I also work in Python, just throws me for a loop every single time, and I hate it. Drives me nuts. Like, I realize why they do it, and there's a, it's not that there is a, it's not that it's wrong or bad. It's just not my cup of tea. Oh, interesting. So it looks like people are actually creating attributes for the function object with the comments and help in them. So that's kind of cool. Yeah, let's do that. So this should let us access the help from within our kernel when we load in our function. All right, so it's an attribute of softmax is what we called this. And then when you ask for help, we should get takes in a vector of real numbers, numbers, and returns the softmax, which is not super helpful if you don't know what softmax means, I guess. And actually, before we do this, let's in our function assert, and I'm going to double quickly check the assert in R, double quick the all right, so this should, this should kick us out of our function if somebody gives us something that's not a vector. So it's not a test, but it's not unlike a test. Assert k, I think we can say is.vector. Vector k. Actually, no, we don't have to check that it's a vector because all variables in R are vectors. No, we do have to check that it's a vector. Sorry. No, we only have to check that it's numeric. So I'm trying to think, so if somebody passed us something that was numeric but wasn't a vector, so something like a matrix or a data frame, as long as it was all numeric, I believe this would still work. It would just sort of make it flat, if that makes sense. So is.numeric, okay. All right, so then if we do softmax k, could not find function assert. Did I spell assert bad? A-S-S-E-R-T. Oh, it's from test it. I see. It's not in base R. Okay, so if we do softmax C1, 2, 3, we should get that out. And if we do softmax C1, 2, and then A, which is not a number, we should get out an error is numeric K is not true. So we've tried to do it, but it's failed because we didn't feed it a numeric vector. All right, Suvik says, not R. Listen, R is a fine language. All right, so I'm pretty happy with that. I'm gonna get rid of this cell. And let's add another assert in here, even though, and I'm also going to add another, make sure we've been given numbers. I should actually check what happens if I give it a matrix. So, matrix. There we go. And I believe when you are setting up a matrix, you can just say like number of rows is 2 and then data equals 0, 1, 2, 3. Oh, right. Could not find function softmax loop. Oh, that's because it's called loops. All right, yeah, so it'll work perfectly fine on a matrix, so we just need to check that it's numeric. And it's like, I guess it's a little bit weird that we say take in a vector, but we can handle a matrix, but it shouldn't, I'm trying to decide if I want to change this comment. I think it's fine. Andy says, what about writing an inverse softmax function, which would depend on an arbitrary constant? Seems like that would help with the intuition. Yeah, that might. I do want to get everything in a utility script, though, just so I can try it out. Because it's a fun new toy, and I worked with the engineering team to make sure it worked. And also I've been politely badgering them about it for about 1.5 years now. Create get constants. Meh, I don't think I need to say what that does. I think that's fairly self-explanatory. And then let's also add a help attribute for softmax loops. Softmax underscore loops. Inefficient use. Actually, I'm also going to say print it's more efficient, faster to use softmax instead. So the help will just say what it is, and then every time you run the function, you'll get a little nagging thing that's like, hey, use softmax instead. It's much faster. All right. So let's take this whole cell and copy that. And I'm going to go kernel.com/kernels, and I'm going to create a script kernel. Make a script, beep beep, and I want it to be in R. And I'm going to call it softmax. I'm going to call it softmax functions. And into it, I shall put my code that I wrote in my notebook. And in settings, I'm going to say that utility script is on so that I can import it into my other notebook. Wow. And then I'm going to commit because when you import a utility script, it will look through your committed files. It needs like a static version to refer to, and if you haven't committed and it's just a draft, it doesn't have that. And here I'm going to go file add utility script. Sort by recently run. I only have the one. I'm going to add it. Oh no, that's going to open it in a new, there we go. I'm going to add it. And then, so it's restarting my session. It's attaching my code that I've written on my functions. And I should be able to, I can't see the session information. Okay, it's starting. And I should be able to, from here, so you can see that I have in my user/lib this softmax functions. So I should be able to run as source, where is it? User lib softmax functions. So we just change the so the title of my script, I almost said notebook, has a space in it, and you can see we've just made it so that it doesn't. And this will run all of the code that's in my utility function. So if I had something that printed out, it would be printed out. But what it's done instead is, so you see I haven't run this cell, and I'm actually gonna, bam, get rid of it entirely. So we haven't defined those functions in the notebook, but because we've run this as source and it's run all that code, we now have those functions in our local environment. And I should be able to, well, it didn't work so good. What did I do? Let's see. Soft. Is it because I included the trailing? Oh, you know what? I don't think I finished the path. Yeah. I need to use, there we go. Bring that back. You need to actually point it to an R script. Gooder. You think I'd never used source before? All right, there we go. And so now, even though we haven't defined it in our notebook, I have this nice little handy utility script I can import. And I should now, so this is the real test. If I do help on softmax, I should get out the little help thing I did. I did not. Do I need to do softmax.help to get the attribute? Maybe it's softmax $help? All right, well, I thought that would work. I'm afraid that random software carpentry, Stack Overflow comment was less helpful than I thought it was going to be. But we done it. Okay. Let's go see it up a little bit. Let's add, so something that I think would be helpful. I don't know why I deleted that whole cell. Andy says, check that you can add an arbitrary constant to the argument without changing the softmax. That's a really good point. That is also something that I think Vladimir suggested earlier. So let's check that out. So let's look at test values, and let's see if softmax test values equals softmax test values plus 1. So it looks like it doesn't. I'm wondering if this is being added as a vector or is being added to All right, so let's do something simpler. 1, 1, 2, and say that that is the same as, and it was addition and not multiplication. Yeah, that makes sense, because multiplication is going to actually change sort of like the 2 times 4 is farther away from 0 than 2 times 1 proportionally. Does that make sense? So that'll sort of increase the softmax, and we wouldn't expect that to be the same. So let's do C. 1, 2, 2, 3. Interesting. So I'm not getting the same values out. We would expect to, though, right? So what's happening here? let's you know, me, let's really quickly check softmax loops as well. True, false, false, true. What if we just look at the numbers? Oh, there's something weird about vector comparison. Oh, there's something weird about vector comparison in R. R compare vectors. An if statement. Oh, that's right. It's all. No, because they're still doing equals equals. Which is the same thing that I'm doing. Identical. That's the one I'm looking for. Let's see what that gets us. Because we shouldn't expect this to change. It's a little bit weird that it does. False, they're not identical. And yet, if I look at them with my eyeballs, they look the same to me. They're the same numbers in the same order. This is a little bit mysterious. So R does not think that these are identical, but me and my eyeballs think that it is actually. So, or is it equals maybe? Maybe there's like a function is equals. Andy says floating point arithmetic. That seems likely. So let's round this. That might be helpful. Round, and I don't remember what any of the arguments are, and then let's say digits equals 3, just to be kind of butts about it, and see if that's equal to this. Oh man, this is hard to read and also looks awful, and I'm there we go. Okay. Andy says there must be some or almost equal function operator in R, and folks are agreeing that it is probably floating point arithmetic. And when I round, it looks like they are the same. Let's see. R vectors equal ignore rounded. Blah 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 blah. Their sum, how to round off numbers, there we go. Test if two objects are nearly equal. All equal looks for near equality. Okay, so we could do all dot equal. Still, nope, not how that's spelled, Rachel. Get rid of all of this nonsense. And see if that's equal to softmax. Do I need one more? I do. I need one more parenthesis. There we go. Excellent. And Keith says total equals 1 absolute greater than or equal to total. Med says why not just calculate the difference between the two? That's a good point, but if it's off, like there's a floating, it's like the difference is in the like very small part of the number that we can't see, then we'd see a difference even though they are more or less equal, where it matters. Which is to say in the numbers that I looked at with my eyes. All right. No, beans. That's okay. It was all dot equals QUALS, and I'm just going to add a little thing here. Check that our softmax is the same when we add a constant to an input vector. Keith says, oh, all dot equal is actually base. I've been trying to use base. micro benchmark isn't, and I think test it assert isn't, but I don't think I've loaded it in any actual libraries. There's, for those of you that aren't super into our community, there's sort of an ethos in writing packages that as much as possible you want to use base R so that it's more portable between people who may or may not have packages downloaded. And then if you are going to use something from another package, to import like the specific function you're using and not the whole package. So if you install a package and it requires something, that's sometimes considered a bit rude if you're not using a lot of stuff from that package, if that makes sense. Community norms are super interesting. K equals C 1, 2, 3. And then we want that to be the same as softmax K equals, and let's actually make it a bigger number, 6, 7, 8. Could not find function all dot equals. I just used it. I just used the function all dot equals. Did I misspell it? Oh, it's all dot equal. I did not actually just use the function all dot equals. That's me being wrong. All right. And then here we did a little bit of benchmarking to see if I don't know, I looked at that and I was like, that's not the word, if loops or vectors are faster. Spoiler alert, it was vectors. It's always vectors. It's never loops. All right. If loop version or vector version of softmax is faster. All right. Let's commit this. Oop. Oh, and I had somebody asked me recently, once I hit commit, can I like leave? Do I need to stay on the the editor screen? And you don't. So once you hit commit, we actually spin up a new VM to run it from top to bottom. So once you hit the button, you can leave, you can keep editing. It is absolutely fine. Import our softmax functions from a utility script. You can see the script here. Okay, this was hopefully super helpful for you guys. Can I edit it? Am I just too zoomed out to see the edit button? I am too zoomed out to see the edit button. This was super helpful for me. I hope it was helpful for you guys. I have like kind of understood what softmax did for a while, but actually sitting down and going through and implementing it has given me a better understanding. And now when I see the equation, I'm going to know that that's softmax, which is super nice, because we have run into it a lot in the reading group and I've just been like, and then they do something with exponents, I guess. Let's get rid of these. I'm just getting rid of the help attributes because they didn't actually print when you asked for help, which is sad for me. So I'm going to commit this. I'm going to make it public. Actually, I'm going to add myself as a... I do have 2 accounts. One of them's for my admin stuff so that when I'm demoing for you guys, you don't see admin stuff. Did I make it public? No, it's still private. And I'm also ineligible to win any competitions anyway, but it is against our terms of service for users to have multiple accounts. So be warned, we have ways and means. All right, and just says, thanks a lot. Thanks a lot for joining. I thought this might be kind of a lesser attended one because I don't know that it's super interesting, but it was very helpful for me. So hopefully it's helpful to someone else out there who's wrapping their head around softmax. And this, did I commit? I haven't commit. And let me also, again, add myself as a user. And that's just so I can edit it more easily from my other computer if I need to. And then make it public. Okay, make public. So if you guys want to use these functions in your own kernels, you're welcome to. They're under Apache 2.0. You will have to fork this. So when you import utility scripts, you only see the utility scripts that you have written. So if you want to use somebody else's utility script, you have to fork it and then commit it. But yeah, I will see you guys on Wednesday. We're going to head back into the reading group. We're learning about multitask learning with deep neural networks. And we're just getting to the empirical results part of the paper, so I think it'll go a little bit faster and be a little bit less me being curly R, fat curly R. I don't know what the difference is. And then next Friday, I don't know. I'll come up with something. I'll come up with something fun for live coding. And I'm liking, so this was an hour later than the time that I've been trying out. And I'm liking the early morning for me time because I think it's better for folks from India. So I might budge live coding to the same time as the reading group is now. And I'll make an announcement on YouTube. And I'll tweet about it, of course. As always, I'm a big Twitter user. All right, thanks for joining, everybody. I hope you have a great weekend or enjoy your weekend if you're already in it. And I will see you guys on Wednesday. Bye.